As functions get more complicated, you might have to use more than one rule to find the derivative. And this problem here, number 30, is one of those cases. You'll notice that we actually have a product here. We're multiplying the function t squared by the function 3t plus 4, all raised to the third power. And so we're going to use the product rule, but along the way we'll have to also use the chain rule. So you know our strategy for using the product rule. We assign the first factor to be our u function and the second factor to be our v function. So I'll go ahead and get set up over here on the left. If u equals t squared, then u prime, the derivative of u, is 2t. If v equals 3t plus 4 raised to the third power, then the derivative here, we're going to have to follow that chain rule. It's also called the general power rule. We'll bring the exponent 3 down. We'll rewrite the quantity in parentheses 3t plus 4, and then subtract 1 from the exponent. That becomes a 2. But then we have to multiply by the derivative of 3t plus 4 because of the chain rule. This is a composition. So the derivative of 3t plus 4 is 3. And I can simplify this to be 9 times 3t plus 4 squared. So u is t squared. We got it right there. U prime is 2t. V is 3t plus 4 all raised to the third power. And v prime is 9 times 3t plus 4 squared. Then writing out the derivative, which is h of t, will look something like this. I'm going to run out of space here, but I'm going to try and squeeze it in. So h prime of t, you know what? Let's go ahead and do this on the next screen. I'm going to rewrite all this stuff and give us more room to work. So let's flip over to a new screen and complete this problem. As you can see, I've rewritten our setup for this problem. Again, u is t squared, u prime is 2t, v is 3t plus 4 raised to the third power, v prime is 9 times 3t plus 4 raised to the second power. So here's how you write that final derivative, which is what we're looking for. We're looking for h prime of t, the derivative of h. And the way we write this out is like our product rule. We write down u, which is t squared, times v prime, which is 9 times 3t plus 4 squared, plus v, which is 3t plus 4 cubed, times u prime, which is 2t. And we're basically done, but I am going to simplify this. Typically what we'll do is we'll write 9 times t squared out in front of the quantity 3t plus 4 squared. And then we'll write down 2t times the quantity 3t plus 4 cubed. And there's all kinds of other interesting factoring we can do with this. But in terms of practicing our derivatives, this is looking pretty good. What you may see, I'm going to go write this in a different color because I'm perfectly happy with this. But just so you know, you may see something like this. You'll notice that there is a common factor of 3t plus 4 squared in both of these. So you might see that factor pulled out, 3t plus 4 squared, and then the leftover terms are 9t squared plus 2t times 1 extra 3t plus 4, because we only factored out the squared quantity. We've only factored out 2 of them, and there's 1 left over here because this is cubed. And so that might simplify to something like this. 3t plus 4 squared times 9t squared, and this is going to be 6t squared when you distribute that, so that's 15t squared plus 8t. And since we're in the factoring mood, you'll notice that there's a common term of t here. So I may as well finish this off since I started it. Let's go to the last screen and we'll factor that thing. Okay, so here it is just rewritten. We've got the 3t plus 4 squared that we factored out. We simplified the other factors and we ended up with 15t squared plus 8, and we noticed that there's a factor of t in both of these. So when all is said and done, we can factor t out of that quantity and end up with 15t plus 8. And then depending on how these are written, I'm guessing that the most common way would be to go in ascending order. The t would be out in front, the 15t plus 8 would be next, and then the 3t plus 4 quantity squared would be last. So that's the completely factored version of the derivative. Remember, we were shooting for the derivative. We arrived at one form of the derivative back on the last screen, and then we went ahead and did some factoring. And this is another form of the same derivative. The key here was using the chain rule to find the derivative of v. And that's really what I wanted to illustrate here. Keep up the good work and keep the questions coming. Good luck.